Hello and welcome back to Geometry. Let's take a look at the example problems from section 3.1, Parallel Lines and Transversals. First up, we have a real-world example of identifying parallel and skew relationships on this block of cheese. Identify each of the following using the wedge of cheese below. All segments parallel to segment JP. So let's highlight. We'll switch to blue here. I think I need a little bit bigger. Segment JP is found right here. So notice from our point of view, that is a vertical looking segment. So any of the other vertical segments such as LR and KQ would be parallel to JP. So we have segment KQ and segment LR. Next, let's find segment, here we'll go, those are parallel JP. We'll go orange next for segments skew to segments KL. Segment KL, oh, it's already drawn in purple there, so we'll switch to purple. Skew to KL. KL is right here. We need something skew, so it cannot intersect it, so that rules out KQ and LR. QR would be parallel to that. So we could use JP again. Notice that even if the sides of this cheese were to go infinitely, this will go here, this one will continue behind it. They would never intersect. And JP would get, and KL would get farther and farther apart. Similarly, these other ones down here, PQ and PR, are on a different plane and would continue in completely different directions here, so they would never intersect. Those will all be skew. Segment JP, PQ, or PR. All right, and finally, a plane parallel to PQR. So I think I'm going to have to get rid of my highlights here so we can see better. PQR. And I'm realizing an orange highlight on an orange cheese does not do much. PQR, there we go. So that would be the bottom side of the cheese, the one parallel to that. The one that with, if this is flat, then what else looks flat to you, flat and horizontal? That would be the top of the cheese, JKL. So plane JKL is the only plane parallel to PQR. Delicious. Example 2, classifying angle pair relationships. Refer to the figure below, that would be this guy right here. Classify the relationship between each pair of angles as alternate interior, alternate exterior, corresponding, or consecutive interior angles. So let's examine our diagram real quick. This line would be the transversal because it intersects the other two. That means everything in here between these two lines is interior. 1, 8, 4, and 5 are on the exterior. So for angles 1 and 5, 1 is here, 5 is here, they are both exterior and they are on different sides of the transversal, so that would be alternate exterior angles. Next, angles 6 and 7. 6 and 7 are both on the interior between the two lines, and they're on the same side of the transversal, so same side interior, also known as consecutive interior angles. Next up, angles 2 and 4. Okay, 2 and 4. 2 and 4 right here. Let's see, 2 is interior, 4 is exterior, so they're not one of the alternate corresponding. Oh, they could be corresponding, actually. Let's think of, from the intersection, I go upper right, and from this intersection also up right. Okay, we'll just call that to the right of the intersection. Yes, they're both the rightmost angle there, so corresponding makes the most sense. Okay, and then finally 2 and 6. 2 and 6. Here we are on opposite sides of the transversal, but both on the interior, so this must be alternate interior angles. Just going to finish my color correspondence there. There we go. And example 3, identifying transversals and classify angle pairs now with multiple intersecting lines. So first we need to identify the transversal connecting each pair of angles, then classify the relationship between each pair. So first up, angles 1 and 3, find those in the diagram. Here's angle 1, here's angle 3. Notice that the intersections here's the actual vertex of 3, here's the vertex of 1. Go ahead and connect those dots. And which line have we run our pen along? That would be, line H. So the transversal between angles 1 and 3 is line H. And then what type of pair do they make? From line H, 1 and 3 are on opposite sides, so they must be an alternating pair. And what is crossing line H? What else is making those angles? That would be these lines here. This is all the interior, and 1 and 3 are not in that. They are outside. They're on the exterior then. So 1 and 3 must be alternating exterior angles. Erase some, oops. Let's erase some of that highlighting. There we go. Okay, now 5 and 6. Let's locate angle 5 right here, angle 6 right there. Connect their vertices. I have gone down, that's line K there. So the transversal for angles 5 and 6 is line K, which means angles 5 and 6 are on the same side of the transversal. And looking at the other lines, that would be J and L there. They're between those lines, so they are in the interior space. So 5 and 6 are same side interior or consecutive interior angles. Okay, last one, we'll go blue. Angles 2 and 6. We had 6 before. Here's angle 2. Connect those vertices 2 and 6 right there. Continue that down. That's line L. So the transversal of 2 and 6 is line L. And 2 and 6 are on the same side of that transversal, but 2 is interior, 6 is exterior. Notice the lines crossing there. 2 is between the lines, 6 is not between the lines. But they are from that vertex towards the right, from the vertex to the right. So they are both in the same position relative to their intersection. That makes them corresponding angles. That does it for example 3, and that will finish all examples for this section. So long, farewell. Enjoy the rest of your day.